Hello again, grade 10s. This video 2, is going to cover question 3 and question 4 of your winter assessment. Question 3 focused on metallic bonding. So if you read the little blurb, you would have automatically recognized that the question is going to focus on stainless steel. 3.1, very easy question. It asks what is the above an example of. If most of you, if you didn't get this right, I would have been very concerned. This is a metallic bonding or alloying. That's what I gave you a mark for. 3.2 asks to explain the process of the bonding, referring to the sea of delocalized electrons. So in this instance, I want you to show me or write that metals, they ionize easily and this leaves empty orbitals, okay? Which thereafter creates molecular orbitals. These orbitals overlap and they are shared, the valence electrons are shared with multiple atoms. Therefore, electrons are delocalized from their parent atoms. And the electrostatic attraction ensures the bonding of metals. I didn't mind how you wrote this. You didn't have to use my words specifically, but as long as it made sense to how this delocalized of electrons comes about, you got 3 marks. Question 3.3 links on to the previous question with 3.2. Here, I wanted you to actually draw a diagram using the DeLorean chassis as a reference for this. So a lot of you, it told me you didn't read this because some of you just drew some random alloy, and that told me that you didn't read the question properly, so you did not get the marks here. Those of you that did read or can read, all right, you needed to show the different size of the positive kernel. You had to show a regular repeated pattern. It had to be labeled, and you had to show delocalized electrons. Now, a lot of you, when you did draw this, you spaced out the positive atoms, the positive kernels, and this automatically minus a mark, so you got 3 out of 4. I don't know why, so that's something we might have to address. But remember, it's a solid, it's a metal, so it is compact, it is concise, it is the particles are closely packed together. It is a crystal lattice. So if we go to my memo, you will see I've drawn my positive kernels very closely together. If your image looks similar to this, then you should have gotten 4 out of 4. Okay. Question 3.4 is talking about greenhouse gases in the atmosphere. These greenhouse gases include carbon dioxide and methane. So you automatically know that the following questions have got to do with carbon dioxide and methane. Here we are moving into covalent bonding. So I wanted you to explain to me, define valency. Once again, bread and butter mark. It had to be all or nothing. You had to say combining power with other atoms when it forms chemical compounds and or molecules. This is the measure of an element's combining power. 2 marks. 3.4.2, very simple question, and this was easy marks. If you had made a mistake in a previous question, you could have made it up here, because all I wanted you to say is that covalent bonding is sharing and ionic bonding is the direct transfer. Where it went a little bit iffy was 3.4.3 when you had to draw the off-bar diagram for carbon dioxide. Now this was directly from the book. You did not have to do I wasn't expecting you to draw a diagram of a compound that you've never heard before. It was from the book. I realized that carbon dioxide is a tricky one. I realized that, but you had to show how they share their valence electrons to get a full octet. You had to show that. So I wanted the arrows to show the sharing. Let's look at my F-bar. I wanted an off-bar for each element or atom thereof, and I wanted labels, and the correct spin was the most important thing. You needed to show opposite spin. So I was a little bit upset, or I wouldn't say upset, but I was a little bit disappointed here when a lot of people didn't get full marks, or at least 3 out of 4 for this one when it comes straight from the book, straight from the book. Following on to this, now that we've asked about carbon dioxide, I had to ask about methane. So I straight from the book again, I wanted you to draw a Lewis diagram of the methane molecule and explain whether methane is polar or non-polar. The trick here was that 2 marks were for explanation, okay, because the charge is neutralized and there's no overall charge, and the other 2 marks were for the drawing. 1 for the drawing and 1 mark for showing the negative carbon and the positive hydrogen. That's what you needed to do. So this is my image over here. A lot of you, I've seen you already, but let's just show it again. Therefore, grade 10s, therefore, you have got 8 marks from this section that is directly from the textbook theory. No, in actual fact, 10 marks, 12 marks that are directly from the book. It's no extension whatsoever. I can understand how the DeLorean can be a little bit of an extension because you are dealing with the stainless steel, but this entire section over here was pure theory, book learning. 3.5. 3.5 was a question that I added just to get a little bit of your opinion once again. I wanted to know what makes noble gas element special, but it also hinges off the theoretical component. And over here, I wanted you to tell me that it's got a full valence shell, or that the noble gases satisfy the octet rule, and that it's stable due to its configuration of electrons. Therefore, it does not need to bond with other elements. That was for 2 marks. So you can see I've given you a few options in the memo that you can use from there. That was question 3. We're going to go on now to question 4. Question 4 focused on waves and EM spectrum. I understand that we've done this already in your control task. We've done this so many times, but this was a nice way to conclude the section. And it was for 31 marks. Therefore, I wanted you guys to concentrate. I wanted you to use at least half an hour on this section because I included both the waves through a medium and the waves without a medium. So in 2015, Marty is trying to escape Griff and his goons. He uses a hoverboard to cross a body of water near the Hill Valley Courthouse. The body of water measures 25 meters in length by 30 meters in width. Okay, so you have the dimensions of the space now. Remember, grade 10s, we give you information, but sometimes we give you irrelevant information. So it's your job to pick out the information that is going to help you solve the problem, solve the physics problem. Question 4.1 was define a transverse wave for 3 marks because it's a nice fat definition. Once again, it had to be all or nothing. If you said displacement of particles and perpendicular, I still marked you right. Question 4.3 says that the hoverboard isn't moving fast enough. In desperation, Marty uses his new Nikes to paddle across the body of water. This paddling creates waves every 2 seconds. The consecutive wave crests are 30 centimeters apart. Calculate the following. Now, the next 8 marks are marks for jam. Easy peasy marks. I did this to ease you into the rest of the paper, which I felt was very, very fair and straightforward. There was no higher learning going on here whatsoever. It was plug and play. You had to figure out the frequency of the wave. You know that the period is 2, so it's 1 over 2. It's going to be 0.5 hertz for 3 marks. Formula, sub, answer. 4.2.2, I had to work out the number of waves. Now, based on the fact that you have the hertz of 0.5, you're going to just take 0.5 and times that by 10, okay? Which gives you 5 waves for 2 marks. The speed of the wave. Now here, you had to do some sort of conversion here, but it was minimal. You had to take velocity is equal to frequency multiplied by wavelength. 0.5 times 0.3 should give you 0.15 meters per second. 3 marks. So out of all those calculations, the third calculation might have been the most challenging, but everything else was pretty straightforward from the book. You have actually experienced and practiced far more complex problems in class and at home in tutorial time. 4.3, suddenly within a second, Marty loses his balance and falls in the water. The fall creates a 2-meter wave. Can you see how I'm highlighting stuff? You should be doing the same in your exam situation. Highlighting the relevant information. That travels to either side of the pond. It travels to either side of the pond. The barrier wall is perpendicular to the surface of the water. When the wave reaches the barriers, it moves back into the medium. What is this a property for? You shouldn't even have to think. It's reflection. Everything, the question gives you the answer, grade 10. Everything in here, it gives you the answer. So here I started moving into a little bit more, let's see if they are paying attention and picking up the correct information to answer their own problems. If the depth of the water near the barrier is shallower, how would this affect the speed of the waves? Here you are going to definitely say it's going to slow down. That's straight from your book. That's straight from your book. But yes, the question does hinge off the previous question. Question 4.3.3, once again within the same vein, giving you the answer based on the question. It's saying here that after hitting the barrier on either side of the pond, the waves interfere. So there we go. You automatically know before you finish the section, you know that we're talking about interference. Interfere close to where Marty is still spluttering and trying to gain his footing. The waves lift Marty higher as he bobs in the water. Name and describe this type of interference for 2 marks. So the first mark is going to be the name of it, and the second is the description. So it's constructive, and you needed to tell me that it's the sum of the amplitudes of the individual pulses. Question 4.4. If Marty's fall generates 5 waves in 5 seconds, calculate the speed of the wave. So simple, but for some reason people struggled here. I think it was a exam anxiety, I'm not too sure, but it's so simple. Guys, 5 waves in 5 seconds, that means it's a wave a second. So it's going to be 1 hertz, that's 1 mark. Then you're going to go, speed is equal to frequency over frequency multiplied by wavelength, so it's 1 multiplied by 2, you're going to get 2 meters per second. That's what I wanted here for 4 marks. And we go on now to the radiation portion of the question, 4.5. Now we are going into EM spectrum. So we leave the rest behind, and we say that Marty travels back in time to save Doc. In 1885, Doc is working as a blacksmith. Yes, I had to put in there a person who makes or repairs objects made of iron, because apparently at grade 10 level you guys still don't know what a blacksmith is. Yes, it's true. The Wild West is dangerous because of Buford Mad Dog Tannin and the strong radiation from the sun. So just by reading this little blurb, you would see what is my key takeaway there, radiation. So I would have this is a scaffold effect. It's like getting your brain ready for the next section. Radiation is where we're going now. So for 4.5.1, I wanted to know, does solar radiation work as the same way as water waves? And you guys needed to tell me it's different, okay, for 1 mark. Then you needed to tell me that radiation is self-propagating, all right, and that it creates an electric and corresponding magnetic field. That's what I wanted to know for 3 marks. 1 mark saying it's different, 1 mark saying self-propagation, and the 3rd mark for saying that it creates an electric and magnetic field. That was for 3 marks. For 4.5.2, I wanted to know the relationship between wavelength and frequency with respect to the electromagnetic spectrum. Here I wanted you to say inverse relationship. You didn't have to, you needed to say that the lower the frequency, okay, the lower the frequency, the higher and energy, the greater the wavelength. So, and vice versa. If I've got a short wavelength, I'm going to have large energy. Okay, if I've got a high frequency, I'm going to have a short wavelength. Okay, then we went on to, based on this, so the only, I would say, tricky part of this is that if you don't know your theory very well, you don't know the basic fundamentals, you cannot apply it to any situation I give you in the exam. Because as you can see, I build upon questions. So, and what I do is I start with the simpler questions and then I build onto a more difficult question. So by just knowing your fundamentals and you're knowing your fundamentals properly, you can apply it to anything, any question. Okay, so based on your answer above, which photon has the highest frequency? Visible light at 600 nanometers or ultraviolet light at 350 meters. So I didn't want calculations here at all. I just wanted you to say ultraviolet light, okay guys, because that has got the shortest wavelength at 350 nanometers. So all you needed to say was ultraviolet light at 350. Then from that, now you've made that statement. I wanted you to back up that statement using calculations. Okay, so I wanted you to do an energy calculation for 600 nanometer visible light as well as for 350 nanometers ultraviolet light. You needed to do for both. That was the thing. Yeah, you needed to convert. Okay, from nanometers to meters. All right, because wavelength, the SI unit for wavelength is meters. So I gave you a mark for that conversion. I gave you the mark for one formula because you could have used either energy formula, yeah? I gave you 2 marks for the answers for the different radiation, and I gave you a mark for the substitution. All right. So from this, question 4.5, I know it's 5 marks, but if you had this is a validation question. It's validating what you have said previously. Okay, so that is the end of question 4 and the end of video 2. The next video is going to cover question 5 and question 6 of your exam, and therefore we will conclude this section of the syllabus.